Hello everyone. This video will help you to solve problems on continuous random variable. As we know, random variable can be classified into two types, a discrete random variable and a continuous random variable. Discrete random variables are finite in nature and the mathematical operation which we will be using will be summation because they are countable and you can count on them. But when you have an interval where you have an infinite number of values, counting them is not possible. Therefore, integration becomes the operation for us. So now we will solve few problems on continuous random variable. Problem number 1. A continuous random variable capital X has a PDF, the probability density function, f of x to be given as k into 1 plus x for the limit 2 less than x less than 5. Find question number 1 the value for k. Question number 2 the probability of x less than 4. Now we will have to solve for this. Before moving on into the solution, we will quickly check what do you mean by a probability density function. A probability density function is going to be defined for a continuous random variable that will have to satisfy two conditions. The function f of x will be greater than or equal to 0 for all the values of x belonging to the real number. The second condition is that when you integrate it between minus infinity to infinity, the function f of x dx will give the total value to be equal to 1. This is going to be the point which we are going to now make use of to estimate the value of the constant k. So how can we apply this to estimate the value of k? So we can say that we know that integral from minus infinity to infinity f of x dx is equal to 1. So this will imply integral from. Now about the quantity, what is our range of integration? 2 less than or equal to x less than or equal to 5. Notice we have a continuous random variable, so it takes infinite number of points, which means 2.5 is also going to lie over here. 3.7, 4.2, whatever be the number you say is going to be inside it. So taking x as 2, 3, 4, 5 is going to be very wrong notion. You are not taking point values, but you are taking all the values in this interval. If it is interval, you denote it by this symbol, less than or equal to x, less than or equal to 5. So inclusive of 2 and 5, all the infinite number that lies within it will be taken into account for. In which case, you cannot write as x takes the value 2, x takes the value 3, x takes the value 4, x takes the value 5. Okay, so this is a wrong notion. So please avoid taking finite or point values. It takes all the values between the interval. In which case, what will happen? My integration is being defined in the range. Lower limit is 2, upper limit is 5. Function f of x, what is our f of x? K into 1 plus x dx is equal to 1. So k is a constant that can be taken outside. So you will have integral 1 into dx is dx plus x dx on integration from 2 to 5 is equal to 1. So this will give me k times of what is going to be integral dx. Integral dx is x, and what is integral x dx is x square by 2 between the limits 2 to 5 equal to 1. So now what we can do is we can just apply the upper limit minus lower limit and then solve for the value. So this gives me k times of upper limit minus lower limit 5 minus 2 plus 5 square is 25 minus 2 square is going to be 4 by 2 equal to 1. Solve for it. K into 3 plus 25 minus 2, 21 by 2 equal to 1. Take LCM. So 2 will be your LCM. 2 3s are 6 plus 21 equal to 1. So k times of 21 plus 6, 27 by 2 equal to 1. So what can we say about k? Cross multiply it to the opposite side. 2 by 27 is the value of k. After fetching the value of k, your task is go and substitute it back in your f of x. So what will happen? Our f of x will now be redefined as 2 by 27 times of the value will be equal to 1 plus x. So k has been resubstituted. So it will be 1 plus x, which is valid for 2 less than x less than 5. So that completes our problem number 1. How about our problem number 2? You want the probability of x less than 4. Okay, so this is going to be probability of x less than 4. So in which case, normally, where is our integration ranging between? Minus infinity to infinity, f of x dx. So this is going to be probability of x equal to x. So now I have 4. What is this 4 now? Less than or equal to 4, which means this forms the upper limit. So it is integral from, the upper limit is going to be till 4, and x takes all the values less than 4. So what are the values less than 4? Where is your f of x beginning from? It begins with 2. So you can write it as integral from 2 to 4 f of x dx. An important point to note over here in the continuous integral is that your inclusion of the number 4 or the exclusion of the number 4 will not much difference, because there are going to be infinite number of points in the interval 2, 5, and so this one number, so you are going to take 2, 4. So for our integration, for this purpose, adding this one number 4 or neglecting this one number 4 will not affect the integration in a greater way. So we need to keep in mind, for a continuous case, for a continuous random variable, the probability of x strictly less than a is the same as probability of x less than or equal to a. The same holds true for probability of x greater than a is the same as probability of x greater than or equal to a. So this point of including that one point a for your integration will not make much difference to the final answer. So now taking it till the limit 4, this now gives me integral from 2 to 4. The function is 2 by 27 times 1 plus x dx. So 2 by 27 can be taken outside. 1 dx on integration gives you x. And x dx on integration is x square by 2. Upper limit minus lower limit 4 to 2. So this gives me 2 by 27 times of 4 minus 2 plus 4 square is going to be 16 minus 2 square is 4 by 2. So this gives me 2 by 27 times 2 plus 12 by 2. So this goes 6 times. It goes 8. 8 2s are 16. So the final answer is 16 by 27. So keep in mind, for you people to recollect, probability of x less than a and less than or equal to a remains to be the same when you have a continuous random variable, but it is entirely different for a discrete random variable, because that one point, whether you include or exclude, will affect the probability in a greater way, because you have only finite number of quantities for evaluation. Now we move on to the next problem quickly. Problem number 2, it says, if a random variable x has the PDF given by f of x equal to 3x square for 0 less than x less than 1, and it's going to be 0 otherwise, then you will have to find the value a such that probability of x greater than a equals 0.05. Over here they have given us the final probability. They are asking us at which point we will be able to achieve this probability. So again we will be taking the help of the definition. What is going to be the definition for x greater than a? X greater than a for a continuous random variable is nothing but greater than a. So a becomes your lower limit greater than a. So the integration varies from a to the upper limit What is our upper limit? The function is valid for 0 to 1. So what is the upper limit? Upper limit becomes equal to 1. So it is integral from a to 1 f of x dx, which is the probability of x greater than a. But what they have said, this is equal to 0.05. They have declared that final answer is this, in which case I need to find the value of a. So how to go about it? So we have integral from a to 1. What is the function? 3x square dx is equal to 0.05. 3 is a constant. X square on integration is x cube by 3. Between the limits a to 1 is 0.05. 3 and 3 can be cancelled off. Applying the upper limit, 1 cube minus a cube is 0.05. Now moving on, what we can have is 1 cube, you take it to the opposite side. 1 cube is 1 minus 0.05 is equal to your a cube. So 0.95 is my a cube. So how to get the value of a? A is cube root of 0.95. You need not have to bother very much. In your calculator, you will find a square root button. On top of the square root button, you will find the cube root button. So make use of your shift operator and then you can key in 0.95 shift and that square root of or the cube root of button. So you will have the value to be estimated and you can find the end value to be equal to 0.9830. So make sure you use your calculator effectively to estimate these values.